So this is the first experiment, amplitude modulation and demodulation. Now let us see the statements in the program. So MATLAB program. So first one is CLC, clear command, and second one is clear all. So whatever variable defined before, it clears all variables. All those variables becomes unknown. So next one, close all. It closes all windows if at all opened in the MATLAB. So AC is equal to 1. So AC is equal to 1. It is amplitude of the carrier. So FC is equal to 0.4. It is the carrier frequency. So FM is equal to 0.05. It is the modulating frequency 0.05. So Fs is equal to 10. So total number of samples. So here it is time is defined here. Time is defined here. T equal to 0 comma 0 colon 1 by Fs colon 200. So first zero indicates initial value. So last one indicates that is the maximum value. So the statement creates an matrix array, column matrix array. So initial element value is 0. So maximum final element value is 200. So 1 by Fs. So Fs is 10. So Fs is 10. So 1 by Fs means 1 by 10. So 1 by 10 means 0.1. So 0.1 is the incremental mode. So it creates an array. It creates a one column matrix. First element is 0.0. So next element is 0.1. Next element is 0.2. Next element is 0.3. Up to so on. So last element will be 200. So just like this we can see, we can observe. Say carefully. Fs is equal to 10 to T equal to 0 colon 1 by Fs 200. So 0 is the initial value and so 200 is the maximum value, then and is the last element. So 0 is the initial value, 1 by Fs means 0.1, and the last element maximum value is 200. So it creates a column matrix. So what are the elements? First element is 0, next element is 0.1, incremental is 0.1, add 0.1, it becomes 0.2, add 0.1, it becomes 0.3, 0.4, 0.5, like this. So up to so on 200. Now we got a column matrix T. And we have another expression within the program. So MSG is equal to cos of 2 pi FMT. So what happened in this case? So cos of 2 pi FMT. So T means, so T matrix, T column matrix is substituted. So each element of the T column matrix is substituted for each value of T. For each element of T, so there is one message sample. So here MSC column matrix is created. So T is having n samples, so MSC is having n samples. So n by 1 matrix, and T is also n by n matrix. So now we got message matrix n by 1. So message samples. So similarly, there are another statement, carrier signal is equal to AC star cos 2 pi fct. So each value of t, each element of t substituted here for each value of element of column matrix T. So there is one value. So another char matrix is created. So char contains carrier signal samples. So first we created a T matrix, T column matrix, and then so message samples are created, and then column samples are created. Now we go to the program. So message is equal to cos of 2 pi fmt. So message samples are created. So and carrier equal to AC star cos of 2 pi fct. So carrier signal is created. Now this is the expression for AM wave. So ST is equal to AC star 1 plus modulation index star message signal into carrier signal, that is star cos of 2 pi fct. So this is a expression for AM wave. So here message samples and carrier samples are substituted. Finally generates AM wave. So ST contains the AM wave samples. Now we have to bother about demodulation. So how to get the modulating signal from the AM wave present in the ST. So we have to call one function AM demod. So AM demod demodulates the AM wave present in the first argument ST. So ST contains AM wave samples. So AM demod function, it is a ready-made function. It demodulates the AM wave samples present in the ST. So second argument is carrier frequency, and third argument is Fs. So finally it returns demodulated signal. So that is available in Y, that stores in Y. Now coming to the plots. Now we want to plot the four signals. First one is message signal, second one is carrier signal, and third one is modulated signal, AM modulated signal, and fourth one is demodulated signal. Okay, there are four figures we want to display. So I want to display four plots in 4 rows and 1 column. So subplot I am calling the function. So first two argument tells the how many rows and how many columns in how many rows and how many columns the plots are displayed. So here I have written 4 comma 1 means 4 rows and 4 columns, and third argument indicates the plot number. Plot number is first plot. The first plot I am displaying message signal. So to display the message signal, we have to call one function plot. So first argument is T and the second argument is message. So plot arguments are plot of x comma y, and x-axis is T and y-axis is message sample values. Okay. So if you want to display the x-axis name and y-axis name, so you have to call the function x label and y label. So if you call x label, so whatever written within the single code, that is displayed on the x-axis. So here I have written time. So time is displayed on the x-axis. So y label. So whatever written in the single quotes, so that is displayed on the y-axis. So here amplitude is written, so amplitude is displayed on the y-axis. So what is the name of the plot? So you have to if you want to display the name of the plot, you have to call title function So to call title function, so within the single code you have to write the name of the plot. So here the message signal is written. So message signal is displayed on the plot. So this is first plot is completed. Similarly second plot, subplot 4 comma 1 comma 2. Okay, 4 rows and 1 column. Third argument says it is the second plot. So what is the second plot? The second plot is for displaying carrier signal. So I'm calling plot x comma y. So on x-axis is t and on y-axis is carrier samples. So I'm calling x label and y label and title. So same as that of earlier one. So subplot 4 comma 1 comma 3 and third argument is 3, so that is meant for third plot. So what is the third plot? Plot t comma st. So plot of xy. So x variable is t and y variable is st. So st contains am samples. st contains am samples. So third plot is meant for displaying the am samples. So modulated signal, to display the modulated signal. So next one, subplot 4 comma 1 comma 4. So 4 comma 1 comma 4 rows and 1 column, and the third argument says the plot number. So plot number is 4. The fourth plot number is 4. So what is that fourth plot? Fourth plot to displaying a demodulated signal. So demodulated signal is present in the y column matrix, y variable. So we have to call plot x comma y. So on x-axis is time variable and y-axis is demodulated sample values. So you have to call the x label, y label to display the names of the x-axis and y-axis, and you have to call the title function to display the title of the plot, to display the name of the plot. So what is the name of the fourth plot? So demodulated signal. So if you substitute my value is 0.5. Okay, there are 4 layers. Message signal. This one is carrier signal. Third one is modulated signal, and fourth one is demodulated signal. Okay, this is all about first program.